Question 10. The diagram shows two rectangles. We have been given the measurements in terms of the width of this left rectangle and the width of this right rectangle. We've been given the height of this right rectangle, but we don't currently have the height of that left rectangle. But we can very quickly add 2x and x in order to get that length. So 3x is the total length of that, and then we already have this and this here. So generally speaking, when you've got this like L shape and you've got lengths involved, a quick habit is to try and find the lengths of anything that's not been given. So we are kind of good to go, ready to roll now. Question tells us that the combined area of both rectangles is 50 centimeters squared. So that means that all of this is 50 centimeters squared. Calculate the value of x. You must show clear algebraic working. So whenever you've got this type of problem where involved in your diagram are unknowns and you're being asked to calculate the value of x, you're not really expected to sort of be able to know straight away what's going on, which also ties into this. And to be honest, you get some questions here where it might just say show that. It might not ask you for calculate the value of x. It might say show that, I don't know, 3x squared plus 16x minus 17 equals 0 or something random like that. And you'll be wondering what on earth's going on here. Well, we're going to end up with this quadratic, something like that, which we're going to be able to solve to figure out this value of x. But that's not where we're going to start with. Where we're going to start with is looking at our picture and looking at the information that the question's given us. And it's all that stuff in blue, which is 50. So our area equals 50, our total area. And so what we're going to start with is actually areas of a rectangle. So our left rectangle has an area that is base times height. So 3x times x minus 3 is going to be the area of that left rectangle there. The area of our right rectangle is going to be our base of x minus 1 and our height of x. So we get the following. And then our total area, which will be these two terms added together, is going to equal 50. So that's where we're going to create our equation. So we have our 3x, x minus 3. Of course, I can break that out straight away if I want. 3x squared minus 9x. And then our orange one, oh, that's red, not orange, plus x, x minus 1, which when we break it out is going to give us a plus x squared minus x, and they're going to equal 50. So as I mentioned before, and as you can see now just by looking at this part, we end up with a quadratic, so we're going to need an equal 0. So taking away 50 from both sides is something I can also do, as well as breaking out those brackets. When the dust settles here, I'm going to end up with a 4x squared, a minus 10x, and a minus 50 equals 0. In order to solve this quadratic equation, there's no mention of rounding, no mention of decimal places or significant figures, which implies this is going to factorize, or it should factorize very nicely. Highest common factor, well, all of these things can be divided by 2, so I could factor out a 2, but because I've got an equation, I could just divide everything by 2, so that's exactly what I'm going to do here. If you don't spot this step, that's fine. You can still answer this question relatively comfortably by factorizing that, or if you want to use a formula, that's also fine. And then at this point here, we're going to factorize it into double brackets. So for this question, I'm going to look at just doing it by trial and improvement. So we have here 25, which gives us 25 at the end and 2 at the start. So we're going to need to think about 50 as our number, or minus 50 even, as a number that's going to be linked to the two things that have to multiply each other out here. And minus 5 is what we want to get when we add these things together. So our factors that I'm listing out now are what we're going to need. And we're trying to figure out which pair is going to give us this minus 5. So hopefully we can see that the 5 and 10 are going to be used to get our minus 5. So if we have a plus 5 and a minus 10, that will work to get this. And then we've got to be careful. We can't just put plus 5 and minus 10 into our brackets like that, because technically the two numbers that are here need to multiply to make that. So the reason why at this point in time we have numbers that are, well, give us a product twice as big is because one of these numbers actually got doubled. And because 5 is an odd number, it can't have come from 2 times something. So this 10, actually, it won't be a 10 that goes there. It's a 5 that goes there. But if we put the 2x here, that 2 is what doubles the minus 5 to make it a minus 10. So we've got those terms there. That all that leaves us with is an x to go here. And that is trial and improvement, factorising a non-monic trinomial. From there then, we have to solve it. So we set each bracket equal to 0 and then solve them individually. So from this, we end up with x equals minus 2.5, or we have x equals 5. Of course, you cannot have negative lengths in any problem involving lengths or area or whatever, right? So we can rule that out. But for the purposes of solving the equation, you should have the workings here showing that you're getting 2 solutions. After which we rule one out, which we've done there, making x equals 5 our final answer. Done.